Okay, so today we're going to cover chapter 7 or unit 5. And we're going to talk about defense in depth a little bit, how to approach cybersecurity solutions, to be able to have more of an advanced solution after you perform the analysis. So you probably heard this term, and we're going to repeat it until you remember, right? Defense in depth is a way that you can have a combination of technical solutions that would allow you to incorporate controls in many different areas to have a more well-rounded protective measure set up for your infrastructure. So defense in depth really aim to control from a technical, administrative, and also physical area, right? So you need to make sure that you understand the categories. In technical control, we have a lot of management capability in technical control, such as configuring firewalls, creating users and groups and assigning them privileges and access based on least privilege requirements. Administrative control, some of that will pertain to how we configure, in that how you're building the policies that would fulfill the regulatory, and we talked about HIPAA, right, PCI DSS, and some of the compliance requirement, also state and federal, that's very important. And then the physical control, how you're controlling your facility, the actual physical devices, how you are preventing theft, and some of that area. So making sure that we know that there are 3 areas that we focus on when we're building defense in depth. Now, for the first question, it asks you to provide some of the example for security control. And these will likely come up on your interview, your job interviews, or when you're thinking about adding some of the technical elements and administrative elements or physical control into your security plan. So technical control is a way that we would configure the system to align with the policies or the rules on security appliance. So for example, I want to make sure that I configure the ports that would work, right? Be available to the services or the protocols that I'm using. But at the same time, right, we talked about vulnerability assessment in the past, how that would improve my security landscape by just, disabling the ports that I don't need, but monitoring or managing those ports, right? So we are gonna configure based on what we should fulfill for security and protective measure. But in that, we want to detect and prevent. Prevention should be your first area, and detection is going to be more of a reactive approach, right? But we know that things will happen, and so we want to detect and prevent internal and external threats. So internal threats could be employees, disgruntled employees. External threat could be your attackers or malware, right? That's coming in from the internet. Administrative control means that we are going to create and apply organizational policies, provide regular security awareness training to make sure that people understand the requirement in security practices. So we would have policies such as password policies, how we want to reduce the vulnerability of weak passwords. We would have policies for data loss prevention in how we maintain our data and control our data access. So the policy, you have to write it out and be able to align that with how you configure in the technical area, right? So these two, they always go together. we might have policies on user acceptable use policy on how they're using the system, what's allowed and what's not allowed to be performed under the system. So there are many different types of policies that would be implemented or updated, right? So a lot of my former students, they would ask me, when should I change the policy? Let's say that you go into a company, you get hired, and they already have policies in place, right? Does it mean that you have to rewrite those policies? My simple answer is whenever you update technology, you have to update the policy because different technology would require different practices, different configuration. So in the case, if you're upgrading software such as operating system, you have to go back and revisit some of the policy that pertain to that particular upgrade. So when you change applications such as database applications, and looking at how that change would, so you have to do change management, but how that change would impact, right, your existing policy and your configuration. Then we have the physical control that pertains to the physical device, the physical facility, the building, right? So we would use locks, barricades, surveillance. And we want to make sure that we detect, deter, and prevent, right? That's our role in physical control. So deterrence could be you using surveillance camera system, security guards. That would also be a form of deterrence. And security guards can be a form of prevention, right? They can prevent someone from entering the building if that person doesn't have the requirement for the entrance, such as identification. And ultimately, we want to make sure that we protect our physical assets, right? Because ultimately, that will be the investment, the monetary investment for the organization. People are also assets, right? So we want to make sure we have physical control to protect ultimately the human beings that exist, that work, that operate in those buildings. That is most valuable compared to the physical equipment or land or things, right? Even though a lot of times we see that, yeah, you can put a value to that building might worth $1 million, but your assets inside that building, besides the equipment, are the people, and human lives is ranking at the top, right? We want to make sure we protect them. So your control could also be like fire extinguisher. That's really important. Fire suppression system. There had been different types of fire suppression system, but a lot of, if we use water system, like in this particular room, most likely that you will damage systems that are running. If you use gas-based system, like halon system, which is now illegal, right? It will damage the people who work in that facility. So you would have to really weigh the risk on what kind of implementation approach, right? There's no 100% way that we would be able to not have any loss. So in the case, our job is to make sure that we minimize the loss, just knowing that loss will occur in the circumstances, like you might face earthquake, fire, storm, outages, and so on. So either you lose data, right? But we want to make sure that we protect you. Okay, any question regarding the areas of security controls? You've seen this in CIS 27 and other security classes. You will see them outside of those classes. In certifications, they will ask you, right, what scenarios. So just making sure you understand how you can implement technology, right, practices, processes for these areas. Okay, So when we go through and look at the layered security, I think right now the value of data is so heightened. It's just the things that we use with data and how data is exchanged or bought and sold, really elevate the value for your personal data. So data security is really a core in a lot of the things that we do and how we break them down into classes known as data classification, or how we would implement technology security appliances to really protect the data. So when you're looking at how we are layering this, so your data is at the core. And what access data you should ask, right? Ultimately, we human either have data input or output, right, through technology. But if you break it down in some area, application utilizes data. When you open up an application, whether it's database or even your app on your phone, it uses some form of data, right? So application security is right outside of data security. That's really, really important. And so when we do assessment, you have to look at each area as an analyst. You start with data security. You ask yourself, does it have classification that's needed? Are there permissions and access control for our data? Then the next level is going to be your application security. What kind of security measures do we have for the application? Is the code check, right? In the future lab, we are going to really look at application code, source code, and looking at how we would be able to screen through. Does it have input validation? So input validation is important because we want to prevent injection ultimately, to make sure that they don't just access the application and be able to pull your data from container. If you learn C++, Python, Java, right, those programming classes really teach you how to create data structure or container for your application to ingest data. And where does that data go? So in the larger scale, we don't write application to store data locally. A lot of times, all of that goes into memory, and we want to take that container and we want to be able to port the data into database, right? A table, whether you want to use relational or non-relational type of data, and making sure that that data is then to be isolated from the application. Because if you store all your data into the application, if your application fail or if it's breached, then your data is lost, right? So we want to pull the data from the application, have it externally stored, use that application to be able to retrieve the data and access the data. And so with that, our system, our endpoint system, your laptop, your tablet, your desktop, right? Those systems access the application which accesses the data. So you, as you can see, you move outward. And then those systems are connected to the network. So in order to remotely access, or I have to access the network to connect to my system, to open up the application, to access the data. So data is still its core. And then on the outside, in order to protect the network as a whole, perimeter security, like firewall, security appliance, the setting up DMZ, having an intrusion prevention system. We talked about that before. So you have to really think about how you are integrating each layer of security and think about how you are ultimately protecting your asset, which is your data. Each of these have its own assets, but ultimately we are looking at the core value on how data is used, right? So data can make or break the company. It can be used for marketing. It can also be used for treating patients. So there's so many different areas. You're looking at specific industry, but ultimately we dive down to how important it is to protect the data. Okay. And then there's a little bit of the zero trust. So you want to remove the trust that is used to place across the systems. services and individual inside the security boundaries. Now, can we completely do this? Probably not. I think that we use certificate and single sign-on architecture and all of those things based on trust, right? So when you visit a website, you have some form of system trust. When you have a session, there's some form of system trust. But a lot of that, if you think about that, that's really external to your system and your network, right? But what they're saying here is using a zero trust model, you have to really look at the level of trust, right, on how systems sees one another and when does that trust is needed. When you remove that, you really have to really dive deeper in thinking about how things are accessed and how things are communicated. So, all right. Let's go and look at the next part. So for number 2, it says refer to the layered security model and provide security control example of each layer. So we'll start with data security. To protect your data, simple, right? We can implement data encryption. So encryption allows us to take raw data that can be readable and make it into unreadable to the people who shouldn't have access to it. And we want to encrypt the data based on classification. We don't just encrypt all data, we encrypt the private data, right? The confidential data. Now, public data can be in plain text and can be visible to everyone, but before we really put it into that class, we have to think about, what kind of information does this data contain? Then you have the application security, as I mentioned before, input validation. If you're not familiar with input validation, it's really a way to check how data is entered into the application. Like when you're filling out a form online, right? For example, if I type in my 4-digit of my social security, it cannot be a letter, right? It has to be a digit. So a way that developer build input validation is that on that particular application, you cannot type in a letter. It has to be number for the last 4-digit of social security. But input validation goes beyond just characters and parameters that required for certain type of numbers, right? Like phone number, social security number, date of birth. Input validation requires developers to really look at, could this be a line of injection, a script, right? So, every form, you normally have a comment box where they can type in a lot of text, right? And we would allow the user to do that. But when you think about application assessment for security, you really have to put in the requirement for it to check, right? What is being inputted into that comment, whether it is a valid text or is there a pattern in the text that would indicate that it is a script. So we also input validate to prevent application error. And if you took my Python Java classes, you probably had gone through input validation requirement for looking at application error, because when you have application error, right, your application likely will halt or you might have erroneous data. So you want to make sure that you have proper conditions that is implemented to check your system requirement, whether it is an error or not. So input validation goes a long way. That will prevent injection attack. We can also do static and dynamic source code check. We will do that later, right? So we'll take a look at how the application is built and looking at whether there are issues with the applications. A lot of the checker or the tools that you use to check your source code it's really looking at the syntax of that particular programming language. Now, application security also, when you do application security assessment, you also have to test the application. You have to look at the code of the application. Sometimes you have to decompile the application to look at the source code. So looking at how it's built is also important. Then we talked about endpoint security. Those are your devices, like handheld devices, like tablet, PC, laptop, smartphones. We might want to have anti-theft systems, right, where we can remotely lock in case if it's lost or stolen. You can use security software to prevent malware from impacting the system. So those are only a few examples. You got network security. We talked about intrusion detection system, that is just an alarm system to sound off. Prevention system block, right, malicious traffic potentially if we set the appropriate rule. Then firewall, we can set different type of firewall and how firewalls can be used to control traffic. And then firewall can also be used to control behavior of applications and system and other things. You also wanted to use authentication for access management, like multi-factor authentication, having appropriate groups and user accounts set up with privilege and permissions for access. And then for load balancing, we want to load balance to block possibly malicious attack traffic like denial of service. So load balance is helpful in availability where it would divert the traffic where other system can handle. So for example, I will not just have one router for my network. I would be able to implement multiple routers so that way they can route for quality of service, right? We can also look at the type of traffic, the priority type of traffic, and be able to load balance based on that. So for example, you're on the freeway, everybody is detouring, right? And here comes the ambulance, right? Everybody pulls over and wait for the ambulance, and we can do it that way. We can regulate the traffic based on most of the normal traffic we would route through a couple of our routers and even setting up proxies. And then for the priority traffic, prioritized network traffic, we can set that up with a different way that we can route or a dedicated route for the prioritized traffic. So you have to take a look at your server roles and the functionality of those roles and how they're needed in the network traffic sense, right? As far as performance and throughput. So bless you. And we want to really overall address the availability piece of the CIA triad in this area. When we talked about perimeter security, that can be physical. So it turns out, you know, those are like those wheels that you go, so it controls one person entering at a time, or in the hotel, they have that rotating door, that's a turnstile based entrance. And so you can add a lot more things to physical security. I think, you know, if you play this back into data requirement, if you're storing like physical files, you know how some medical offices, even though they have digital, they still have forms that you have to fill out like for treatment and things. And then they get scanned, right? So those forms need to be protected somehow. Number one, they cannot fall into the wrong hand. Number two, you gotta fireproof the storage for it. So, you know, and then how the files are stored and how they're disposed. You gotta think about the physical security too. They can't just throw it in the trash. Because dumpster diving is an issue, right? So you have to implement shredders and a lot of the other equipment just to make sure that they're properly disposed. Okay, so before we talked about jump box, do you have any question for me? Okay, so this is important. Segmentation So when I taught 41D, which is the class after this one for advanced security practices, and 41D really plays on this, right? Because you have to redesign the network and implement security plan for that. So physical segmentation of networks and systems are important. Things like we want, for example, at this college, you're gonna have student area of the network, and then the staff and the faculty area of the network, and then the district, right, which overlooks the 3 colleges. Ultimately, all of those combine into a larger network, but you would have a student segment where student will not be able to access some of the critical servers that stores like transcript for everyone, right? You're able to retrieve your transcript through the application, but you are not able to access, for example, compared to a student service director who would be able to pull up anybody's file and anybody's transcript, right? So that's access level and also segregation of how the systems communicate is important. You also need to think about isolation of system, right? Whether you want to remove the air gap or connection physically, and also ensuring that on the infrastructure at the logical level, you need to isolate. Those could be like your sandbox, your tested system, things that could impact the larger network. So we might be able to test like updates and upgrades to our software separately on a virtual machine or a group of virtual machine, and we would isolate that in an area of the network that will not impact the rest of our operational network. So you can virtualize the segment, right? You can also set up VLANs to segregate the network. So here are some of the benefits, and we want to place the firewall between the network segments. This might sound overkill, but the whole point in separating the network is to make sure that we have perimeter blockage or control in that, right? Think about the DMZ. If you don't, that's a separate side of the network that's public facing. So if you don't place a firewall there, anybody can come through that side from the internet to come in, and we don't live in 1990s, right? We live now in the present where we have the technology in order to implement that. Okay, so if you want to find jump box or server, you can go to page 2. The jump box, it is a segmental environment type of system. It allows you to manage access for that particular segment. So you would see something like this in the diagram. You would have a jump box right here. So when you look at this diagram, you have the internet, which is everybody is coming in, our connection to internet service provider. This one, we have a firewall pair. They place it here to simplify that, but it's really a firewall on the outside, the router, and then an internal firewall. So when you're coming in from the internet, you're gonna hit an external border firewall, and then it's gonna be the router, and then after that, you're gonna be connected to an internal firewall, right? Then you have some web application firewall. Why is that there? It's there to really control some of the public access or things that are requested for application and web servers. Okay. Then you have a VPN device or server here, and that is really for remote access in this particular infrastructure. Now, the VPN connection is going to be tied to the jump box. This is a device, a physical device or a server system that's going to control access specifically for the VPN connection. So it works with the VPN server for authentication and access authorization. Then once the credential is passed and checked, then it's going to allow the user to remotely pull up their desktop, which is part of the private network, right? Is this setup critical and completely required? No, there are many ways to design or redesign the structure, but this is one design that's using the jump box. Any question? Okay, so let's look at the next one. So it says, describe the purpose of the jump box in securing the organization's infrastructure. So we can use a jump box to access and manage devices that are in another security zone, such as the demilitarized zone or DMZ, and the organizational network. If you look at the diagram that's included in your notes, you can see that it's used for that. It's also used for virtual private network, right? VPN. So you can think about like your network is made of a many subsegment. Think of them as like little small community, right? We might have a big county, and in that county, you might have small cities. And in that city, you might have small communities. And in IT networks are like that. You might have different segments for departmental use, or specific requirements for like application or system usage. And in that, what we can do is we can set up security appliances or systems to be able to control access for those smaller segments. So in the case that if you're looking at remote workers, the users would connect to jump boxes via virtual private network, VPNs. And then with that, they would be able to authenticate and access, right, their remote systems.
We have this in our notes.
Page 2. Any question? So let's say if I don't use jump box, can I use other features on the server? Yeah, definitely. You can implement other things. In this particular case, right? They mentioned that the textbook that I was referring to for the notes point to jump box, and you see some of that in the solution. So in the case, if you're asked on interview whether you know what a jump box is and how it's used, you can think about like this example, using it via VPN connection. Okay. So for the next section, we're going to talk about, so for jump box, right, server and information, see page 2. And then the next section goes over network architecture. Now, all network design has some kind of flaws, right? If you aspire to be a network engineer, in the case that if, we have to really look at like, what can we redesign in some sense to make sure that we still have the availability, but have the security component as well. And sometimes that can be a challenge. Because if you have something that's been established for, let's say, 30, 40 years, back in the day, even though the network has been upgraded throughout, right? You've seen and probably heard people say that, oh, they basically change everything on the network and build a data center. It's just because sometimes it is a lot harder to go back to fix something that's very old and replace everything with new. But that's not always the case, because you have operation that still require network connectivity, and you cannot just pull everything apart and restructure and recable and buy new computers and set it up. It takes time, right? We gradually would implement solutions in segments. So you would find like the least impacted area and you would start with that first, but you also want to address the priority of need. So here it talks about physical network architecture and how you would look at network appliances and systems and cabling and how that can also be a part of control. So simple, right? If I cannot logically attack a system, I can simply go and cut cable. Okay, so how do you protect your cables? And so if you looking at like the proper practice, you would see that, you know, oh, thank you. Okay, so what you would see is that the systems, right, how it's connected, how it's powered, that's also important. And then implementing the roles of this system. So the next part here talks about software-defined network, your SDN. And this is a way that you can do network control in a centralized way. We can use application programming interface. You can use this for automated type of environment. So simply, it is a programmable network, right? And so this is why your Python scripts, or even shell scripts or PowerShells is important. This allows you to control, right, how your systems are communicating, and even also we can implement encryption, or we would be able to control how our vendor or partners are connecting to our systems. So your SDN is pretty prevalent in the network environment. Okay, so for 4, it says, how can organization implement software-defined network, or your SDN, to secure its infrastructure? We can use it to centralize controls through the integration of application programming interface, your APIs, for monitoring, detecting, and prevention. So monitoring, detection, and prevention. So we can use this to integrate the software, right, which is with API, to be able to monitor the type of threats and the vulnerabilities. And in the case that if the threat is detected, right, we can manage that, we can contain it, we can respond to the threat, we can isolate it. Logically, you can isolate that through the SDN environment, and then you can also prevent, right? We can set up the type of rules and system configuration to be able to manage that. So a quick example, right? How can this be implemented? You can use Wireshark API, right? You can use security tools API to be able to communicate with your centralized system like SIEM. So you have the data and analysis from your security management system and be able to understand what kind of things you need to modify in order to make sure that you have a better infrastructure. So with that, we will implement APIs, and that's part of the software-defined network. And sometimes this can also be like using protocols that allows you to manage network, synchronize, so on. Okay. In the next section, it talks about virtualization. So before we answer that, I can point that out too. Virtualization is on page 3. As you probably have seen in every lab that we use, right? If you're using Kali Linux or Windows, it is a way for you to have more practice in a virtualized environment. But virtualization ultimately use hypervisor 1 or 2, and it allows you to access your virtual desktop infrastructure, your VDI. This will let you access your operating system. So even on the cloud, right? We saw in the last in the last lab, we saw AWS, but I didn't use EC2. So if you use EC2, you will be able to have instances where you will be able to configure your virtual machine on the remote server that's owned by Amazon or Microsoft. So you can run desktop operating system and secure, and you can run that with the virtualization. You can also implement that on the security appliances. These would be a lot easier to manage, secure, and control. Okay. So with the virtual environment, not only that it saves us money, but I think the management capability in the virtual environment is very good. And then another term that you see is containerization. This would be an alternative virtualization in that you would have a dedicated container, really down to the storage, to be able to store appropriate configuration files and the libraries. Maybe for applications or so I know that we did a lab that requires Docker, and Docker is exactly that, right? It is a way that you would set up an environment that will be controlled, and we would have a container to store all the things that you need. So Docker, and then if you look for a job, you might see Kubernetes. This is a very common tool, right? So if you want to explore, learn about it, add that to your resume. A lot of people are looking for that type of skill. Okay. So if you have threats that are impacting the operating system, right? It would impact the container services. So how can we control the security for the container? You got to make sure that you have signed container images with the tools. And with that, it would have to have some form of trust for the tools or some kind of validation for the tools. We want to make sure we monitor the application inside that container and the services. And then you want to go back and audit. So monitoring is different than audit in that monitoring you do it live and it's current. Audit is something that you look back, right? In like the logs and events that had occurred. So you got to look at what's happening now and what had happened in the case that you're using container or just live system. Now, you saw before, I think if last week, if you used AWS, you probably seen the term serverless, right? Or we talked about cloud using serverless. This is running function as a service. It really just use system to execute specific function. We talked about that. Okay, so let me move 4 and 5 to the next page so we can see them together with the next few questions. Okay, so for number 5, it says, how is VDI or virtual desktop infrastructure used in organization infrastructure? It can be used to virtualize desktop, servers, security appliances, and containerization. And we don't just virtualize for testing, we virtualize for deployment, right? For usage, for operation. This will allow you to save costs in hardware, but it also allows you to have more of a control. Now, it's going to come back to the technology that you use for virtualization, whether you're using VMware, that will be vSphere, right? For the virtual server. If you use Microsoft products with Microsoft Cloud, that will be your Hyper-V, implementing with Azure. So there are many different types of products that are available for virtualization, but ultimately, if you have a virtual desktop infrastructure, it can be for different types of systems, right? Like your computer desktop, your PC, your servers, your appliances, or your Docker or Kubernetes. And we talked about container. So to manage container, make sure that you control the actual container's access rights. So when we say access rights, that's like activity and processes that can be executed for that container, like running applications or changing, application settings. Those are access rights. You need to monitor system and services inside the container. You need to make sure you patch applications so we update it and update the operating system within it. So a lot of the things we do in the container, we have to do in the regular system already. So whatever that you already implemented for your IT infrastructure, you need to apply that to your container. Because it just a set of application and system and services that you use, right, inside a storage area that's dedicated for that. And then we want to audit. So with all of this, when we're looking at infrastructure and networks, it consists of many different type of systems, right? You have a vast of diverse technology and also application. Some system would require specific sets of application that would be unique. Some would be across the network. So when we do asset management, we would take a look at the type of assets and we would tag the asset. So tagging the assets could be, if you look at the monitor, that's, where you're sitting in the back, you would have a barcode. Sometimes they would use some kind of numbering system, but a lot of them would use like the barcode. That allows them to track the physical assets and also help support and maintain that particular system. So in the case that if it's down, right, I can refer to that system because the monitor and the tower are two different components for that system, so they're tagged separately. Most companies, they really determine like what is the minimum value for the assets to be considered an asset. Right, so normally, I think for RCCE, it's $500. Some organization that asset value can change. So let's say that I buy a system, a server that costs $10,000. It's definitely going to be tagged. It's going to help us know and track, right, physically where that system is. And also how we maintain it over time. So let's say if it's a Dell or an HP, I would be able to have that in my inventory and say that that HP server, right, needs to have some kind of maintenance yearly. And if we have the warranty, HP would have to do that because you would void the warranty if you start servicing your system within a year, right? And then if you have extended contract with the company that supplies you with the system, it is a good way for us to kind of monitor that as well. And, having this can deter that. So normally we want to make sure because, normally it would say the company's name. If you look, it says RCCB, right? And then some kind of information about that organization in the barcode. So it does do some deterrence. Question. So it's just a simplified way for asset management. Okay, so I put down some tools for you, right? This is really good if you're looking into the direction of like IT management or even going into support, also would be useful. There are many different type of products and asset tagging is there. And let's talk about logs. So how we manage logs is important because logs really tell us the story of what had happened. Log is a way that we can go in and audit, right? It's a component for audit. It is a way for us to respond to an incident. So we have to make sure that we protect the log files because attack can go and delete your logs and you would have no trace of that attack. And this is what happened in a lot of the organization that you would hear on the news, like Caesar, right? They had attacked or events that would lead to the larger attack because it's been breached before. It's just nobody was able to detect it. And it's possible that they delete the logs. So your log files need to be secure. And we want to centralize that for monitoring purposes, right? A lot of the security management system would centralize and allow you to use the logs for monitoring, but not always. So if you have an environment where you don't have that, you got to make sure that you have these two elements. Okay. So for when we have a separate log system or servers, we can then manage it, but you still have to use that for the analysis. And here it talks about using a Bastion host, which is a remote log server to maintain log integrity. So for question 8, it says, what is the role of Bastion host in events logging? It is used for remote log server, which is used for centrally monitoring and analysis of the IT infrastructure. So when you hear the term Bastion host, you know that it is a remote log server. Now we have to secure such hosts, right? Because Bastion hosts contain important. It's a way that we can access important information about occurrences, right? Incidents, potential issues that exist in our networking system. Okay. So as we learned in the first unit, to make sure that we have confidentiality, you would use encryption. And encryption is helpful in protecting our data. We talked about that today. But the important part about the encryption is its key, right? Encryption is a way that we convert the data into something non-readable, unreadable. And we would use an encryption key or two to do that, right? One key to lock and the other key to unlock, or we can share the key. So encryption key must be secure, okay? And once you use the key to decrypt your data, your decrypted data must have permission control. Because the decrypted data it would be readable to everyone if everyone has access. So you want to make sure that you only permit, right, individuals or systems that are requiring that data. So we want to make sure we have access management for those decrypted data. And then for data in transit or keys in transit, we must protect that, right? So in some sense, you are going to transmit the key using encryption, right? And then once that key is received, make sure that it is secure. That means that we protect it. So how you store the key, where does the key go, who has the key, you know, admin and root always gonna have full access to keys, right? And then how the key is exchanged in some system or application, you know, people send the key or send authentication information for that key. So we want to make sure that that type of data or that type of transaction is protected. Very important. Because it's a lot easier to take the key compared to trying to break the encryption, right? Some encryption, even with the processing power that you have for powerful computers or bots, you would see that it would take a long time to brute force those type of algorithms. Or enumerate, I should say. We want to also have centralized CA stands for certificate authority. This allows you to reduce issues with compromised key, right? Or change vendors root CA. So when you set up a trusted environment, you are going to have certificate authority. It is a role in your system or server that would issue, right, certificate for trust. And with that, you would utilize this for things like Kerberos or other things that would be encryption related. So whenever that you see encryption, certificate is always following right behind it or with it, right? So this is a way that we can control or reduce the risk of key compromise. And with that, we need to manage the certificate life cycle. When you have certificates that are issued, right, expired, you need to monitor your certificate and make sure that if you have web-based certificate, make sure that expiration doesn't happen, because in the case that if it's expired, it doesn't work. Okay, so where can I find the information for certificate? It would follow right after encryption. This is not CIS27, so I don't break down to some of the algorithm, right? You should know that by taking CIS27, but you need to understand how to protect, right? Or how to implement security solution for encryption. Because a lot of people say, oh, just use encryption. That's not just it, right? You use encryption and you have to do, right, to maintain it, to make sure you secure it. And then the certificate information is here. So digital certificate is for all systems, especially if you're using cloud. Okay. Next, we're going to talk about active defense. So in the next section of the notes, it talks about active defense and why is this important? So active defense is a proactive approach. And I think it took us a little bit of time to get here to really understand the type of security practice and processes and tools that we need to make sure that we are preparing, right, or over preparing in most cases for potential damages. So active defense would help the organization in that it would control the damage when attack happens. And it could be that we would use this by countering adversaries. Now, this sounds like you would attack back, right? In the sense, ethically, we don't. Right? It's not advisable to attack back, but it is advisable for you to put up control that would stop the attack or prevent future attack. Okay. So in that case, we have to really assess how someone, right, can attack us and how we would be able to close out the issues and prevent that from happening. So reduce all the vulnerabilities, right? Think about defense in depth overall and implement the practices on the daily basis. Continuous security monitoring and implementation is the key. So with that, we need to make sure that we're on top of threat intelligence. gathering information about weaknesses and threats. He would also be active in threat hunting and countermeasures. So what's the difference between threat intelligence and threat hunting? Is it the same? So when you look at a job, it says cybersecurity analyst capable of performing threat intelligence, threat hunting, and adapting security solutions. What does that mean? I already said threat intelligence is information gathering. You can do it passively or actively, right? You did some of that. What about threat hunting? What does that mean? Oh, no? Well, you should care about this because this is what you do.
That's purposely going out to get it, to look for it, right?
Yeah, so let's say that you work for a company, right? And they hire you to do threat hunting. Tell me what you're gonna be doing. So, look for what? Yeah, so it could just be like malware, right? Or it could be internal threats, like insider threats, right? Like people who commit fraud, right? So I have students, former students now that this is the area that he operates in as an analyst, threat hunting. Right? His job every day is to connect with the client systems and he has to find as many threats as he can on that, for that client, put together a report, send that to his manager, right? And they charge that client based on the information, the things that he finds through the process. Okay. In a lot of cases, right, for him, they already have problems because, it's like, you're not gonna take your car to the mechanic. That's wrong with your car, right? Very few people will actually maintain their car before it breaks down, right? Because they have the resources to do that. A lot of the times when they reach out to you and they said, can you help me with this area? You already know that they already have threats somewhere, but they can't find it. So you have to go and find it. So you have to find what that is that's hurting it. So some of it could be malware. He told me that there was one case that it was embedded and it was hidden and it was on their archive and all their expert inside that organization, they couldn't find it. So he was able to detect it, right? And then, so that means you have to go and look at the logs and go back and that could take a long time and you will have to use the tools and find the things. Because they're gonna tell you, I don't know what's wrong, find me what's wrong. It's like going to the doctor, say, I'm ill, but I don't know exactly what's wrong with me, right? So you're gonna have to find what that is, okay? So threat hunting, and then once you find it, you're gonna have to find ways to prevent it from happening again. So in the case that if we find malicious software that's impacting that system, then maybe that their security software is not effective, right? Or that malware potentially is not known, so we have to report it and find ways to fix that. And it could be other things outside of malware, but that's a common threat. Okay, make sure that we evaluate continuously. We want to change control. So people buy security solutions out of the box. You see this with advertisement for security firms all the time, right? We implement solutions for your ISO, blah, 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 requirement. Here it is, right? But you need to make adjustments, making sure that it fits for the organization, and we need to do this over time, continuously, okay? So it's not a one-time done deal, right? It's great when things are not happening, but that time we can use to go back here and look at what additional technology issues that we would have. And then looking at how we can adjust the control to adapt. Okay, it's really important that, overall adaptation is, the fluid in that is critical. I just went over the simple definition with my 27 class this week. We talked about honeypot. So honeypots should be used in a way where you can control it. I would not advise someone to use honeypot if they're not able to control their honeypot. You need to have segmentation and you need to have preparation when you use honeypot, because ultimately anything that would connect back to your network is connected. And if things are connected, they can get there, right? So honeypots allow us to really analyze attack traffic. What can be attacking and who's attacking. It's a way to lure the attacker into an area of the network potentially that should be segregated, right? And then you want to also put honey files and things like I mentioned to the other class where it looks tempting. Okay. So we would use technique and tools to really implement solution and countermeasure based on the analysis that we perform on the honeypot. So that's going to give us some of the clues and details on who's targeting us and how we're going to be more proactive in fixing the problem before it happens. So honeypot information is following that on page 4. Right, we talked about infrastructure and cloud a little bit last time. So very important that you control access. So on all cloud, you would see IAM, Identity Access Management. Okay, that's what we used to create user accounts last time. You also look at how they have the type of services they have for security. That's important. And then your CASB, we touched on this last time. This is going to allow you to implement the policy. You know how when you create the users in group, you can select the security templates that would be appropriate for certain type of groups of users, depending on the type of services they use for that particular cloud container. And then for the virtual private cloud, this should be semi-isolated, right? And also control with access. We don't have to do a lot of the physical protection with the cloud because that's done by the service provider, but logically you still have to do the technical and the administration part, right, for the security. Okay. So for 12, how should cloud access security broker is used in infrastructure security? It's used to enforce policy when cloud resources and services are used. So resources such as buckets, right? Storage, virtual machines, service, right? That could be like web services, web application uses web services, authentication services. So those would be tied to your ports and your protocol. And then the resources are often tied to container or system-based components. Question. So let me move 11 and 12 down. And then. So there are 3 forms of controls: preventative, detective, and corrective. Okay. Preventative control, this is an emphasis in security practices all the time, right? It's really a continuous way. We want to make sure that we continuing, right? We are monitoring. We can add monitoring there too. So using firewall blocks, so it prevents intrusion prevention system also works there. So not just firewall, right? But awareness and training programs for your employees would also be a preventative measure. It is a good way for people to learn how to do things in an effective, secure way, right? So training your users and employees for security and requiring that is a preventative control. Detective control, right? Going into intrusion detection system logs and see what event had occurred. Also looking at surveillance or alarm system, like let's say you have a video surveillance system. Detective control is if you're looking at it live and you see someone entering your building, that's not authorized. Alarm system, right? Someone is breaking into the building, so that's impacting the physical security. But detective control can also be your security software detecting a malware, right? So there are many examples in this area that you would see. So you can add more to it if you like. Then you have corrective control. We can have anti-malware containing or quarantine our the malware. So using anti-malware application to quarantine or stop malware infection. Patching, right? Patching is a corrective control. Why is it not the other two? Well, people always tell you update your system, right? But the reason why there's updates is because it's broken, right? So it is not a preventative measure because so I sat in an interview yesterday and people were hiring faculty, right? People talk about preventative measure and they talk about update and patches. Update and patches, it does close out the gap in security in how it reduces some of the vulnerability. And in the long run, you see that it is impacting here. But if you're looking at that form of control, it is a corrective control because operating system updates, there's issue with that, right? They're fixing the issue, so it's a corrective control. Okay. Technically. Okay, so this can be a lot, right? Like I said, you don't have to put verbatim. I just list a lot of things because I want you to have information that you need, but you can add and subtract. So when you're looking at a host can be any system, right? Let's look at it from a scale of an enterprise level host, like a server, okay? A host can be your desktop or your laptop, a computer. But if you're looking at from a host that would be like a centralized system for the company to use, we want to make sure that there's authentication to that host. We want to make sure that that host cannot just have access, can be accessed by anyone who doesn't authenticate. We want to use host-based firewall. I should put host-based firewall, sorry. So if I have a Windows server, right, I would be able to use Windows firewall that comes with the operating system or even the Linux firewall. So we can use an application-based firewall and implement that with, integrate that with the system. We can also use HIPS, host-based intrusion prevention system. So your security software, if it does its job, right, it's going to fulfill those two bullets, the second and the third bullet. we need to do DLP, data loss prevention. So how can I do that? Right, this ties with permissions, but we can do that with encryption, right? So these two can go with DLP. And then DLP, we can think about like, where is that data stored? How is it accessed? Is data in use? Data in motion? So DLP entails a lot of things, right? With data in motion, data at rest, and so on. And then we can whitelist and blacklist, allow or deny. So whitelisting means that we would have a set of allowed, maybe websites, URLs, or activities. And blacklist is a deny list. So we can set this up with ACL. Access control list. And then we can use security software, as I mentioned, anti-malware, antivirus. We can patch. We can manage vulnerability. So that means you have to scan and look at your vulnerability and find ways to fix it. So let's say I scanned the vulnerability and I said, everybody use sweet password. Well, change your password policy. So edit your policy on that system, on the setting, and then educate your user and require them to have stronger password on that host, right? System hardening, this also entails this, but system hardening can also mean a lot of things, right? I can update firmware, I can, so system hardening has other categories. Configuration management, we want to make sure that we manage the type of settings, and based on this sometimes is correlated with change management. So if you patch or install updates, that can also change the configuration. If you're using Windows, that's sometimes that happens. You can also monitor your file integrity. So how do I do this, right? Hash-based validation here, and then check your logs. If it is Windows, event viewers, and then physical access control. So if I store the server, right, I gotta make sure that it is in a secured lock area. That's not everyone can have access. So think of this as like a list that you go through, like a checklist, and some of the things that you already, it would encompass in other areas, but in a layered security approach, you're gonna have a lot of things on your list. Okay, so let's look at 15. It says in analyzing the infrastructure, identify the appropriate view based on the given activities. A, examine occurrences of incidents and events based on the current or historical data. So when you're analyzing the infrastructure, when you're looking at the past, right, or the current activities that's happening, that's called operational view. Okay? Because that's happening in your operation now, or it has happened like yesterday. So events that already occurred or currently happening now, that's part of your operational view. When you're analyzing infrastructure, and in the case that you're using a network diagram to evaluate network design and weaknesses of that design, that's called a logical view. Okay. And in a logical view, we can look at how the systems are connected, or the layout of the room, the cabling, so the network design can tell us, right, maybe we're lacking some security, system connection, and so on. So that will be logical. Because if you think about a network layout, right, that's a logical layout. And then C, evaluate the system configuration, settings, and services in the infrastructure. So if you go into your system information or your services, right, in Microsoft, you can call up services console or settings. And when you go in and check that, when you're doing an audit or evaluate those things, that's called the technical view. Because all of this pertain to our technical systems, right? So technical view. So an element that's really hard or difficult for us to control is the human errors. So how can we reduce the human error in IT infrastructure? So if you ask the person to do something 50 times, likely that there's an error in that 50 occurrence. So you can tell the system to do it 50 times exactly and perfectly how you want it through programming, right? Through scripting, through scheduling the tasks through your software. If you automate that, okay, you can reduce the error. But if we ask the human, right, to do something, we can automate the monitoring and we can sound out an alert or send notification in the case that we can detect the error so we can fix the error. And then we want to control how the activities can occur, right? Because if you don't do that, right, it can, the scope can change, the activities can impact other things. So we can constrain the interface to allow only permitted activities. Do you guys know what this means? So simple, right? If you go to Coinstar, if you ever use it, there's only a few things you can do. You can press start, deposit your coin, and press finish, right? So they are constraining the activities to that task to eliminate additional error, because if the prompt asks me how many quarters am I deposit, I might type in the wrong thing, right? It's gonna let the machine determine pennies, quarters, dimes, nickels, and anything that I deposit. The human only have to press start and finish. And as it finished, it prints out a receipt and I can take that to cash it in my phone. Very simple. So that's a way to reduce the human error. If you go check out, now I see, and Redbox is not as popular anymore because everybody's streaming, right? But I do see them here and there. And you see the interface, right? It's only that. You use Netflix, that's constraining to the activity, right? You can only use, and it's to your account too. So if you subscribe to things, if you take a look, they only give you, so it's constraining to the permitted activities. A lot of things, a lot of application has that. And then we want to implement procedure check for separation of duties and other personnel's procedures. So that means that we don't want someone to do everything because that could generate illegal activity, like fraudulent activity. So we want to have a check and balance. So if you know, I have account payable manager or account payable staff, right? They cannot issue their own paycheck. I want to have another staff check their work for account payable, right? That means that they would pay invoices to companies that are partnering with us, but not. And the paycheck part is usually contracted out. That's external. A lot of companies do this to prevent fraudulent, right? So you want to implement procedural check and separation of duties to make sure that you're protecting your assets, your people, and your money. And then we have training and awareness program requirement to prepare staff for threat detection. I think this area right here, if you teach your people how to communicate and report effectively, it does well for security. So for example, right, like if they see someone strange in the building, they need to notify someone, right? Instead of just ignoring it and go on their way, regardless of the culture. Because some culture are more like, keep to themselves, and then other cultures are more open to, for depending on where you're operating. But and then also reporting in a way where they're not afraid to report. I think a lot of times people think about IT and security, they're like, oh, I don't want to get in trouble, right? I had found a USB and I plugged it into my computer and something strange happened. And instead of reporting, sometimes they stay quiet, and sometimes that can create bigger issues. So I think allowing them to be more open in the communication through the training is probably effective. There's some research in that area too, on the human factor part. And then for the activities that you want to implement for maintenance, we want to do schedule reviews. That's gonna really look at like the tasks and the activities that we need to perform for our security maintenance. So outside of the life cycle itself, right, we want to make sure that we come back to the beginning step, and it is continuous for maintaining security processes. We want to make sure that we have CIP, continual improvement processes. And then things that don't work well for us, and or old rules that are no longer effective, you want to have processes to get rid of them. Right? Just like how you have processes to get rid of your system. And then we want to document the retired processes and policy. Why? Because sometimes, right, we have to go back here to find out like issues or discrepancies and so on. And that would be the end, my friend. So let's stop recording.